Alrighty, welcome back, boys and girls. It's your main mathematician, Shane, coming to you live from Summit Academy. In this video, still working on that interim practice for the interim number 3. So this is going to be part 2. So we're still same objective. We're going to be able to summarize what we have learned from trimester 3. So number 10, picking up where we left off from the last video, it says which of these equations define y as a linear function of x, and it says select all that apply. So that just means they're going to have multiple answers. So let's say multiple answers. Make sure you remember a couple different things that when we are looking for it to be linear, we can have the equation, the graph, and the table. So when we're looking at this, if we look at the equation for linear, that just means that the degree is going to be equal to 0 or 1. So that just means the power is going to be 0 or 1. So we're going to say highest exponent of x. When we look at the graph, it has to be a graph of a linear function is going to be a straight line, and the table for a linear function is going to be a constant rate of change. So it's going to be the same thing from each point to the next one. So that would just mean that the slope is not changing. So these are all for linear functions, but we're looking for nonlinear. So we have to find the ones that are not linear. You can also look at the graphs if you'd like to be able to tell which ones are straight lines, but you can say, okay, the ones that are not linear, well, the first one, that's going to be a linear function, so we're not going to pick A. However, for B, that one's a nonlinear because the exponent is 2, so we're going to say that B is a nonlinear function. Since the x is in the denominator, we're going to say that C is going to be a nonlinear function. However, D is a straight line. Same thing with E, that's also a straight line. And F, however, since the exponent is 3, we're going to say that F is going to be a nonlinear. So we're just looking for the ones that are nonlinear in number 10. Then if we look at number 11, it says Damon is playing with his remote-controlled car. And a couple of things that we have for this. So it says he increases its speed for 15 seconds. He stays approximately the same speed for the next 15 seconds. Then it says he increased its speed again for 10 seconds, and lastly, he then slows it down to a stop for the last 20 seconds. So it says to select the graph that best represents Damon's remote-controlled car speed over time. So let's look at each of these graphs one piece at a time. And what we can really look at is this first one right here. So we're just going to look at, is his speed increasing for the first 15 seconds. So speed for the first 15 seconds, well, on this one we can say that this one's going to be no, because from 0 to 15 it's actually decreasing. So we're going to say that one is decreasing. So as that's going down, it's going to be decreasing, so it's not going to be D. Then we can say for the next one, for C, which going in reverse, let's say for this one, this is also increasing, but this one is increasing, so this one's good. However, we have to go to 15 seconds. So notice on this part right here, we're going to say not increasing the entire 15 seconds. So because of that, we're going to say that it cannot be C. Alright, so then let's see what B looks like. B is actually sideways. It doesn't work out because there's two, we're going to say the two different points. So that cannot be that one because we know that we're talking about one remote control car. So it should just be one line. And then lastly for A, well, process elimination, it should be A, but let's find out. Well, we're saying from 0 to 15 is where we're at. And so since we're increasing from 0 to 15, this is increasing from 0 to 15, we know we're good. So we're going to say A for that one is good. Then moving to the back of this page, we're saying for number 12, the graph shows change in enrollment of a school year for 10 years, or of a school for 10 years after the school opened. During what years did the school have a declining enrollment? So we're looking for something that has where it's declining, meaning it's decreasing. So if we look at this curve, this is from right here to here, so this is going to be increasing. This is also increasing. This is no change. And then from here, from this point to this point, this is what we're looking for. This is the decreasing. So we're saying, okay, what goes along with that point? Well, we're going to say from year 8 to year 10, which is going to be D. So just make sure that you're saying, again, since it goes down, it's going to be decreasing. Then for number 13, it says tickets to the three showing of a certain movie cost $2 more than tickets to a regular showing. Then it says Oliver bought 5 regular tickets and 4 3D tickets, and the total cost was $89. The situation can be represented by a system of equations. So in this first one, we're saying certain movie ticket costs 2 more than, which is going to be this one right here, and then the next part is the price of it. So it says he bought 5 regular tickets and 4 3D tickets for a cost of $89. So that's going to be this equation right here. Then it says, what does the term 5x represent in this situation? Talking about this value right here, which is in our second equation. So it has to be something in this second equation. So it says Oliver bought 5 regular tickets and 4 3D tickets, and the total cost was $89. So we're going to say that, well, it has to be something with the regular tickets. So we know that we can cross out B and D because we're talking about we know it's going to be the regular tickets. And so we're trying to say, okay, well, the number of regular tickets Oliver bought or the total number of dollars Oliver paid for regular tickets. Well, since it cost 5, or since he bought 5 of them, and our price, again, this is the cost, since that's the cost, we're saying that it is going to be C for that one because, again, the number of regular tickets is actually just X, but since we're looking at the entire term of 5x, we have to make sure that it's going to be the total number of dollars that Oliver paid. Then for number 14, it says Anita and Brad are each riding on the same bicycle path. And it says Anita began riding at the start of the path and is riding at a rate of 18 miles per hour. Then it says Brad began from a spot 10 miles ahead of her and is riding at a rate of 13 miles per hour. So for part A, 2 different parts, so there's going to be multiple points. So for part A, it says to write a system of equations to represent X, the number of hours it takes Anita and Brad to travel Y miles along the path. So let's do that first part. So we're going to say for Anita, it gives us a rate of 18 miles per hour. So we're going to say for Anita's equation, we can write it as y equals 18x because this is going to be, distance traveled, where this is, this is going to be the total distance traveled at this rate. And then for B, we're saying, let's do blue for Brad. We're going to say Brad began, it's going to be 10 miles ahead, and it's going to be at a rate of 13 miles per hour. So same set up, but we're going to now actually say it's going to be 13x plus 10 because we have to say that his speed was 13 and then he started 10 miles ahead. So that's just going to be part A, is just setting up those two equations. Then for part B, it says after how many hours do Anita and Brad meet on the path? And show your work or explain your answer. So to be able to do this, all you have to do is set equations equal to each other and solve for x, because that's what we're trying to figure out, is x is the number of hours. But if we're setting these up again, setting them up as y equals y isn't going to be helpful. So what we're going to actually do is we're going to set it up like this. I'm going to set it up as this side is equal to this side. So what we do is this. We set it up like a normal equation. So we're going to say 18x is equal to 13x plus 10. So you need to be able to solve it like this. So since I have variables on both sides, I'm going to subtract one variable term from both sides. So I'm going to subtract 13x from both sides. Subtract 13x from both sides. So this is going to cancel out. The 10 comes down. And 18x minus 13x is going to be 5x. Lastly, since I have variable equals value, I can divide both sides by that coefficient. So I'm going to divide both sides by 5 to get rid of that coefficient. And so I'm just going to say x equals 2. So we're going to say x equals 2 hours. So you have to make sure that you're setting them equal to each other. Also make sure, just like always, you can check using Desmos. So let me pull up our graph here in a second. And let me make it a little bit larger. Okay. And so what we're going to do is we're going to type in our two equations. So I have one of the equations is y equals 18x, and my other equation is y equals 13x plus 10. And so if we look, again, notice how I have two lines. I have, actually, let me switch those two colors real quick. We did pink and blue, we'll say. We'll do blue. Okay, so we said Brad was blue and Anita was the pink one. So try to find where those two lines intersect. Again, be able to find where they cross. And you should be able to click on a point. And if you notice how that value is 2, 36. So again, that's an ordered pair, but we're looking for just the x value. So again, say it's going to be just that point. So always make sure you can check when you have those equations. Always make sure you can graph them out. Alrighty, so make sure you can set these up. Be sure to ask questions as they arise. And as always, super slam that subscribe button.